students, in the previous lecture we have discussed about the qualitative aspects of the electrolysis. Now in this lecture we will discuss about quantitative aspects of electrolysis process. Means on passing how much amount of electricity we will get, how much quantity of the product at the electrode, which we will discuss in quantitative aspect. Now this quantitative aspect can be understood with the help of Faraday's law. But before going to the Faraday law, we will discuss some general concept. We all know that the charge on one electron is 1.6 into 10 raised to the power minus 19 coulomb, and in 1 mole there are Avogadro number of electron, means 6.023 into 10 raised to the power 23. So we can say that on 1 mole of electron, basically we will multiply these two terms to get the total quantity of charge on 1 mole of electron, and this we will call as Faraday, which is represented by the symbol F. So we can say that 1 Faraday have charge equivalent to 96500 coulomb approximately. Now we will discuss the Faraday first law of electrolysis. What it says, it's very simple. It simply says that the weight of the product which we will obtain at the electrode is directly proportional to the quantity of electricity which we will pass through the circuit. So to replace the constant of proportionality, we need some constant. Here we have the Z. Z is the electrochemical equivalent, and we can say that Z is the ratio of W by Q. If we will take the charge equivalent to 1 coulomb, then the weight of the material which is deposited at the electrode is the equivalent to Z, that is electrochemical equivalent. Now we will make it more clear by taking one example, like consider the half cell reduction reaction of silver plus iron. It will gain 1 electron to form the silver. Here we are saying that this 1 mole of electron, basically it will produces the 1 mole of silver ion. Means on passing 1 mole on electron, we are getting 1 mole of silver. So now in 1 mole of electron we have understood it have basically 96500 coulombs of charge. So it will, and in 1 mole we have 108 grams of silver ion. So but now we have to find out the value of Z, and Z we will find out on passing 1 coulomb of electricity. So Z for silver, it is equivalent to 108 divided by 96500. So we all know if we multiply or divide by 1, it does not matter. So here we have multiplied in the denominator by 1. What does it basically 1 means? This 1 is basically the 1 electron, means the n factor of the silver ion. And n factor we all know in case of atom, it is the valency or the electrons which are needed for the reduction by any ion, and it is 1 here, so we have written 1. We will make it more clear by taking another example, like here aluminium 3 plus, on gaining 3 electron it will form the aluminium. Here on passing 3 mole of electrons we are getting 1 mole of aluminium. Now 3 into 1 mole of electron carrying 96500 coulomb electricity, and we are getting 27 grams of aluminium. So for 1 coulomb it is 27 divided by 3 into 96500, and it is Z. Z is the again electrochemical equivalent for the aluminium. So here 3 is basically the n factor for aluminium ion, which is 3. Now we will put this value of Z in the above expression to get the value of W. W is equal to ZQ, and Z we have determined, basically we can write 108 divided by 96500. What does it 108 implies? It is basically the atomic mass of the silver ion. In case of atom we have atomic mass, and in case of molecule we have the molecular mass. Divide by 96500 into n factor. This is the general expression for Z. So we have put it this value of Z in this expression to get the value of W. W now becomes molecular mass in case of molecule or atomic mass in case of atom into Q. We all know it is I into T, means the current which we have passed and the time for which it is passed in the circuit. So into IT divide by 96500 into n factor. Now we all know the molecular mass or atomic mass divided by n factor is the equivalent mass, which is represented by Em. So we have replaced this by the equivalent mass. Equivalent mass into IT divided by 96500. We also take this molecular mass or atomic mass in the denominator of W, and we know that mass by molecular mass is the number of moles. So in terms of number of moles, we can say that it is equivalent to I into T divided by 96500 into n factor. Now we will discuss the second law of Faraday. According to this law, if we connect any two cells which are in series combination, then the ratio of the weight which we will obtain at the respective electrodes is equivalent to their equivalent mass. And equivalent mass is, we all know, is ratio of molar mass by n factor. So let us consider the second law of Faraday by taking one example. Here we have taken two cells. One is of silver cell and another is copper cell. Here we have the two silver electrodes and here we have the copper electrodes. So these silver electrodes are dipped in aqueous silver nitrate solution and copper electrodes are dipped in aqueous copper sulfate solution. And from here the battery we have connected, current is flowing. We all know that when we connect any two resistors in physics, the current which we will pass is the same. Similarly here we have the two cells and these are connected in series. So the current which we will flow through this circuit is the same, and also the time which we will have taken is constant. So the weight deposited at the electrode silver and the copper electrode is directly proportional to the equivalent mass of the silver and equivalent mass of copper. This is what Faraday's second law of electrolysis said. Now let us consider one numerical problem. According to this, question is the electrolysis of dilute aqueous NaCl solution was carried out by passing 10 milliampere current. Then we have to find out the time which is required to liberate 0.01 mole of hydrogen gas at one of the electrode. We all know at the cathode the reduction of water will take place when we carry out the electrolysis of dilute aqueous NaCl solution, and it will liberate half mole of hydrogen gas. So we can say multiply it by 2 to convert this, to remove this factor of half, and we will get the equation: two water molecules, they are gaining 2 electrons to form 1 mole of hydrogen gas plus OH negative ion. So for 1 mole of hydrogen gas liberation, what we will need is the 2 Faraday of charge. So we have to require for 0.01 mole of hydrogen gas. So for 0.01 mole of hydrogen gas, what we will have 0.02 Faraday of charge will be required simply. Now there is no requirement of any special formula. We all know its simple formula: Q is equal to IT. I is the current and the time for which it is passed. Current we will have given in the question, that is 10 milliampere, and we will convert this milliampere into amperes by multiplying this 10 raised to the power minus 3. So from here we will calculate the time. Charge we will have calculated 0.02 Faraday, and 1 Faraday we will all know it will carry 96500 equivalent of charge. So from here we will calculate the time, and on calculating time comes out to be 193 into 10 raised to the power 3 seconds.